So the even bigger picture, just to put this in an overall, bigger context, is, for layman's terms, you can think of the relational model as tables and joins is what it gives us, right? It doesn't tell us how to design those tables, okay? It doesn't tell us how to design these things. My viewpoint, there really are only two predominant techniques for how to design tables today, right? There's what is referred to as entity relationship modeling, which is like normalization and denormalization, right? Some simple denormalization for performance purposes, type of stuff that we're all pretty, familiar with. And then there's dimensional modeling, which is a whole cookbook, of different things that you can do. This doesn't work for you, try this. This doesn't work for you, try this. This doesn't work for you, many dimensions. This doesn't work for you, snapshot grain fact tables. This, so it's a whole, technique of, different, modeling techniques that you can use to store historical data. And, major advancement, at the time for what it did. But, the other things to keep in mind, ER modeling is not a temporal data modeling technique or methodology. So you hear all this stuff of Kimball versus Inman, right? They say dimensional modeling versus third normal form. It's like apples to oranges, right? Dimensional modeling is a temporal data modeling technique. Third normal form has nothing to do with how to store a history of data. It doesn't tell you, what types of time things to put in your keys or not, right? It's not an apples to oranges, type of argument. And in fact, normalization, and temporality, are completely different things. They're kind of compatible with things. And we got the guy who invented sixth normal form, Hugh Darwin. He's in my LinkedIn group. And he's in there and he's saying, yeah, sixth normal form is not a temporal data modeling technique, right? It was invented based upon how to store historical data in databases, and it even isn't a temporal data modeling technique. So people just need to get kind of clear on these big picture kind of concepts. So again, dimensional modeling is a temporal data modeling technique. Anchor modeling is another technique out there that you guys may have heard of, and that data vault modeling is a kind of a type of that, and that's actually what Inman is recommending now. My joke with Inman is he doesn't like me either, right? Inman now, he just now has a methodology for how to design your data warehouse. Right? He didn't have a temporal data modeling technique, okay, until now. So, how much can you be talking about, data warehousing, architecture, right? When you don't have, the core of it is how you design your data warehouse. And if you haven't had that figured out, how do you talk about how the other components around it all work? I don't get how he's gotten away with that up till now. But now he has one, okay, which is data vault modeling. He's kind of, advocated somebody else's technique there to fill that void for him. So ability and performance, those are the priorities for dimensional modeling. So the users can easily traverse it, okay? So they can relate to the star schema diagram and know how to use it, okay? That's the priority for dimensional modeling and performance, okay? Bitemporal modeling prioritizes completeness, accuracy, and reproducibility, okay? For some people, I don't know, you may be like regulators, algo traders, actuaries. These things are more important than being able to relate to the star schema diagram as an end user, right? Our performance. At some point you say, I got to give the priority to accuracy and completeness, and the performance, let's see where it will get me, right? And that's one of the big things today about bitemporal. We really don't have good characteristics on where you do get into the crunch. Yeah, there's performance issues, but my thing is always, where's the wall, right? Don't just tell me subjectively that it's an issue, right? Where is it a problem? Under what kind of workloads and volumes?
Is there a specific vendor tool for bitemporal modeling, or is that just done in a normal modeling tool? So interesting. So there are people who have things out there like kind of to convert requirements into bitemporal models, into it's something which is just kind of coming out there. So there are some kind of entries into that space. Yep, very good. And that's actually one of the other things is that you can think about it. So okay, your job is to go design this dimensional model. Okay, you got to read some books. Kimball's got 1,000 articles out there. He's got books this thick. You got to read all of them. Okay. To design your bitemporal model, okay, just as a baseline, you can think about what do you need to do? Take your third normal form model, okay, and add 4 timestamps, right? And you know what you have? You have the richest level of support for historical information, that you can have.
more than dimensional modeling. How hard was that to model? Right? Now, that's a little bit of an oversimplification, right? Because there are, some things, but, that is one of the advantages is, it's not this subjective, is it a fact, is it a dimension, is it both? Should I make it this kind? It's just, you can think of it, and, it's a little bit of an oversimplification, but you really almost think about it like that.
So you're applying this to a normalized database?
It's a way of thinking about it. Think about you have a third normal form design, right? You've done your logical data model, it's in third normal form, okay? Add the 4 timestamps to it, and you're done. And you have the richest level of support that you could have. Admittedly, it's an oversimplification, but you can begin to think about it that way.
Nightmare trying to put reports off of that, though.
No. Right? I mean, because I've just given you the framework. I've just given you the framework, right, for every type of query that you would want to do against it.
But you're doing that on a table-by-table basis when you have to join 20
Right.
tables.
But I can tell you how to join those tables together.
You just put overlap on top of it.
Yeah, there you go. Okay.
Yeah.
We want to get to the good stuff. All right. So here you go. So here's a sample star scheme, and so I just kind of have fun with this. That think about the typical type 1 slow changing dimension. We have a transaction grained fact table, an accumulating snapshot grained fact table. Type 2 slow changing dimension, bitemporal fact table. Type 3 slow changing dimension, periodic snap. Oh, I update the facts in that periodic snapshot grained fact table, and this one I don't update the facts. Right? Okay, or vice versa. Okay, so. It's just interesting to think about of all of the different menu items that Kimball gives you out there, how they relate to this analytic framework that I gave you for understanding the temporalness of data. Okay, and then you start to get to this thing that I talked about earlier. Contrast this to this analytic framework, and then what does it mean when you're joining these things with all these different types of temporality? Hard for me to wrap my head around. Okay, but one of the touted benefits of this model is that end users can just have at it. Okay, they can have at it, but I don't know if they really understand the results that they're getting back when they join these things with different types of temporality. How is this user-friendly or conducive to performance, especially if you start doing, like there are custom ways to add bitemporal data to star schemas where you start doing that, and now you're mixing in a further concept into the mix, okay? And you're putting in something that it's not, geared performance-wise, so it's really going to be a slow way to implement bitemporal data versus if you have a design and a database engine that's meant to specifically support it, right? Your performance is going to be much better. So the touted benefits, which I would even argue if they're the right, priorities of dimensional modeling, seem to disappear under closer examination.